Okay, so for number 13, we are given this pair of parametric equations. And for item A, they ask us to make a brief table of values of t, x, and y. So our parameter t, it goes from -5 to 5, which I've put in here in this table. And for all these different values between -5 and 5, I plug them into these parametric equations. And so once I did that, I constructed here this table. So this is the table of values which relate t, x, and y. So we can check that first item. And for item B, they want us to plot the pairs in the table and complete the parametric curve indicating the direction. So let's draw this graph here. And I'm going to scale it a little bit differently. So I'm going to, on the x-axis, I'm going to scale it with 4. So 4, 8, 12. And on the y-axis, I'm going to scale it with 5. So 5, 10, 15, and 20. Same thing here. -15 and -20. So once we've scaled it appropriately, we can now plot in these values. So when t is equal to -5, our x is going to be 11 and our y is going to be -18. So our x is somewhere here and our y is somewhere there. When x is when t is -2, x is going to be 8 and y is going to be -9. So 8 and -9 somewhere here. When t is 0, x is going to be 6 and y is going to be equal to -3. So about here. When t is 2, x is going to be equal to 4 and y is going to be equal to 3. And when t is 5, x is going to be equal to 1 and y is going to be equal to 12. So somewhere here. And this is the line. So as we can see, it is a straight line. And the direction that we're going is in this direction. So we begin here at this point. So this is when t is equal to -5. This is when t is equal to -2. This is when t is equal to 5. So that's it. We've drawn the curve. We've drawn the direction of the curve, so we can mark it complete. And for item C, they want us to eliminate the parameter to obtain an equation in x and y. So we have an equation in x as a function of t and y as a function of t. Now this curve here, we can describe it as a function of x, right? Where x is an input and y is the output. So that's what we're going to do. So we're given that x is equal to -t plus 6. So I'm going to bring t to the left-hand side and x to the right-hand side, which means therefore that t is going to be equal to -x plus 6. And once I've isolated t, my equation for y is equal to 3t minus 3. So what I'm going to do here is, instead of t, I'm going to plug in the value of t, but as a function in terms of x. So y is equal to 3 times t, and t is -x plus 6, and then -3. And then we have to just simplify this a little bit further. So y is equal to, I'm going to distribute it 3, minus 3x, and then 3 times 6, 18. 18 minus 3 plus 15. And this here is our parametric curve, expressed in Cartesian coordinates. However, we're not done, because we can see that the parameter, it does have an interval. If we didn't put an interval, it would mean that this curve goes on infinitely, which is not the case. So since we're treating x as an input here in our curve, we're going to have to limit x. And we can see in the table that x goes from 11 to 1. So we're going to say that x is less than or equal to 11, greater than or equal to 1. And so this over here is the equation, the parametric equation, but in terms of x and y. So we can put a check mark here. And lastly, they want us to describe the curve. So we can just say that this is a line segment. So we're going to say a line segment connecting the point. So the initial point where it begins is at 11 comma minus 18. 11 comma minus 18 to the point to the final point, 1, 12. So we're done here, and that is it for item 13.